So we're going to talk about 3 different rules that help us when we're trying to write our electron addresses. So the first rule is called the Pauli exclusion principle. So the Pauli exclusion principle states that no 2 electrons in an atom can have the same 4 quantum numbers. So no 2 electrons can have the same 4 quantum numbers. So remember, those are N, L, ML, and MS. Now, if I have 2 electrons in an orbital, okay? If 2 electrons are in an orbital, then they're going to end up having the same N, the same L, and the same ML because they're in the same orbital. But we can't have the same all 4. So that's why the MS is plus a half and minus a half. So if there's 2 electrons in an orbital, the N's are the same, the L's are the same, the ML's are the same, but one would be a plus 1/2, one would be a minus 1/2. So this one would be different. So we could have all the same, but the last one we could have, or we could have none the same, okay? But that's usually where people get a little confused, because if there's 2 electrons in an orbital, they have the same 3 beginning quantum numbers, but not the MS. All right, our next rule is the off-ball principle. This is not necessarily a rule as much as a process that we're gonna follow when we put our address together. So the off-ball principle is the process by which the periodic table can be built by successively adding 1 proton to the nucleus and 1 electron to the appropriate atomic orbital. So you'll see when I start talking about in the next lecture about how to actually write the electron configuration, but the idea is, say I have 10 electrons. I have to write the address for all 10. And so if I'm doing that, I'm gonna start with the first electron. I'm gonna write his, then I'll do the second, then I'll do the third. I'm just gonna slowly add on. So what it means is where I start my electron configuration, I always start in the same place. I always start with that first electron. Doesn't matter if I have 1 electron or if I have 20 electrons, I always start in the same place with that first electron. So if you notice when I start writing my electron configurations, it's going to be the same process because I always start with that first electron and then I add on until I get to the total number that I need. All right, our third rule is Hund's rule. Hund's rule says that the most stable arrangement of electrons in orbitals of equal energy is the one in which the number of electrons with the same spin is maximized. This rule we'll see when we start drawing our orbital diagrams. So when we draw orbital diagrams, there's going to be little lines that represent the orbitals, and we're going to put the electrons in. And so the idea here is that if I have electrons to put in, I want to put them all by themselves, and then I want to pair them up. Okay? So if I had 6 electrons, I wouldn't go single paired, single paired, single paired in each of my orbitals. I would do single, 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 and then paired, paired, paired. Okay? So that's what this is saying. And we'll practice this when we start getting to drawing our orbital diagrams. I'll refer back to this rule. All right, so now we have our 3 rules. So now we can start actually writing our address. Where are my electrons located in my atom? And that's my electron configuration. And that's what we'll talk about on our next lecture.